In this video, we are going to see the circular frequency shift property of DFT. So DFT we know, discrete Fourier transform. So circular frequency shift. What happens in frequency, that is in Fourier transform, when we shift RF x of n by the terms of e power j 2 pi ln divided by capital N, where n represents the endpoint and L represents the number of frequency shifts. So we are going to find the DFT for this. We already know the formula for finding DFT, that is DFT of x of n is equal to summation of n equal to 0 to infinity x of n e power minus j 2 pi k n divided by capital N. This is a generalized formula for finding the discrete Fourier transform of x of n. So we need to find the DFT for this particular thing. So instead of x of n, you take the whole, so summation n equal to 0 to infinity. Instead of x of n, we are going to take all those things. So x of n e power j 2 pi l n divided by n into e power minus j 2 pi k n divided by capital N. So which is equal to, on simplifying, summation n equal to 0 to infinity x of n e power, so we are having minus j 2 pi j 2 pi n common, so n into, what else we have, I have taken minus k, so it will be plus k, and here there is no minus here, so I am taking on minus, so minus into minus it will become plus here, so divided by n. So we know it is DFT has a periodicity property, so we can add, it is repeating at n times since it is having periodicity property, so I am adding an n since of periodicity, so k minus L divided by n. So on seeing this, we can have summation of n equal to 0 to infinity x of n e power of j 2 pi, instead of k you are having all those things divided by n. So DFT of x of n is equal to summation of 0 to infinity x of n e power minus j 2 pi, instead of k we are having all those things, so we can write this as capital X of, instead of k, all those things, so n plus k minus n, and also by modulus, representing in modulus x modulus of, here it is n, so k minus L circular modulo, this one. Okay, so this is the circular frequency shift. When it is time, in time it is frequency shifting, your Fourier transform will have k minus L times shifting. So with this we are going to see an problem. So x of n is a finite sequence with x of k is equal to 0 comma 1 plus j comma 1 minus j. We have to find what will be the value of x of n d e power j pi n by 2 into x of n. For this x of n, what will be the value of DFT x1 of k? We have to find it. So we need here if you see there is a frequency shift e power j 2 pi. So when we relate with this, so that is x of n e power j 2 pi l n by capital N, which is equal to capital X of circular modulo of k minus L n. So while comparing these two, we are having L is equal to 1 and capital N equal to 2. So we can have capital x1 of, that is we need x1 of k, that is the DFT of this particular time division axis x1 of n. X1 of n is equal to 1 of k minus, here the value of it is 1, the modulo of excuse me, it is actually it will be 2 power 2, so it will be 4, so n is equal to 4, which is equal to 4. So from this we can say it is the shifting of 1 times. So here x of k is this, so we have to shift 1 times, so it will be equal to, we have to shift one time, take this last term to the front, 1 minus j 0, then 1 plus j, then 1. So if we have k, supposing k equal to 2 modulo, then you have to shift this particular sequence of 2 times, or this one again. So you have 1 minus j 0, 1 plus j. Okay, so this L value determines the shifting positions in frequency domain. Thank you.